Hey guys, uh, I made a video a couple of months ago to diagnose and fix P0016 crankshaft camshaft correlation fault code, but I'm doing this quick video right now to give you some more ideas about the new generation of the VVT or CVVT, which doesn't work with engine oil anymore. Obviously, because many cars are equipped with the CVVT, which works with the engine oil, and obviously you have the VVT solenoid or oil control valve as well to control the oil passages for advance and retard chamber. But on the new generation, we have eCVVT, which is electronic continuously variable valve timing. So in this new generation, we don't have OCV anymore, and CVVT doesn't work based on the engine oil as well, but it does have an electronic motor, so ECM can control the advance and retard of the eCVVT directly. So what happens if you have the eCVVT? How can you fix the car if you have P0016, which is a crankshaft camshaft correlation fault code for bank 1 intake side? I also received some comments on the previous video as well. Some guys were asking about some more guide for some cars like Kia Sorento UM 2016, which obviously that car doesn't have CVVT. Actually, the previous version, it doesn't have the old type of CVVT anymore. So your diagnostic procedure could be different when you have the new generation. So today I'm using the DTC guide because I wanted to just make this quick video in case you have that kind of eCVVTs. Hopefully it's gonna be helpful for you guys. Okay, so basically the information that I'm providing to you, it could be helpful for any car that does have eCVVT, but generally speaking, it's based on the Kia and Hyundai workshop manual and DTC guide. So if you have any Hyundai and Kia car with eCVVT, this one can be helpful exactly step by step. For any other cars, still can be helpful, but it might be a bit different. Everything I'm showing to you, this DTC guide is based on Kia Sorento UM 2015 to 2020. Any other Kia and Hyundai car with this engine, with the engine that is equipped on this car, which is gasoline engine 2.4 GDI Theta 2, they will have same strategy to diagnose this fault code. Okay, so first of all, this is obviously the fault code that I'm talking about. Let's have a look at the wiring diagram first, because wiring diagram is a bit different. If you remember P0016 fault code diagnostic procedure in the previous video, obviously crankshaft position sensor and camshaft position sensor, these two still can be possible causes as well, because this fault code is referring to the timing. That's why if you have oscilloscope, it's not really a bad idea to check the waveform between these two sensors. So after checking the waveform, you can make sure if the timing is okay or not. We have some strategy to check the camshaft and crankshaft position sensors as well. I discussed all these in the previous video, so you can still refer to that video to find the diagnostic procedure. But on this video, I want to focus on eCVVT, which is completely different from the previous version. So here you see eCVVT motor, which is connected directly to the engine ECM. This one is the engine control module. And we already have two wires, just two wires. So these two wires, one of them is the positive, the other one negative. So power supply and the control line, they are both connected to the ECM. So you only have two wires and you don't have oil control valve or VVT solenoid anymore. But how you are supposed to check it, this is the diagnostic procedure. So first of all, out of those two wires, you have one of them as power supply. So these two wires, you see this one? If I zoom it a little bit for you. So this is the electronic eCVVT component. You see that here. I have two wires. The orange one, which is connected to pin number 1, this one is the positive or the power supply, and the other one, pin number 2, which is black, this one is negative or control line. So if I check here, what is suggested on the DTC guide is you need to turn the ignition on and check the voltage between pin number 1, which is the power supply, and chassis ground. What you are supposed to get is battery voltage. So you turn the ignition on. You don't need to start the engine because you are just checking the power supply. So you turn the ignition on and check the voltage between pin number 1 and the chassis ground. You should have the battery voltage over there. What about for the control line? For the control line, same strategy. Again, you turn the ignition on, but this time, instead of checking the voltage between pin number 1, you check it between pin number 2 and chassis ground. And if you remember, pin number 2 is for the control line, is for the ground. So when I check the voltage between pin number 2 and the chassis ground, I should get 0 volt. If I check the battery voltage from pin number 1 and 0 volt from pin number 2, it means wiring side is okay. But sometimes you do have this problem, wiring is okay. There is something which can be really helpful, and obviously it's quite easy. You can reset the eCVVT values, and for this one you need to use the scan tool. So it's not complicated at all. It's really easy. You can do it in a couple of minutes, but you need to have the scan tool. So if you are using any sort of universal scan tools, you just need to connect your scan tool. In the system selection, you need to select the engine, and after connecting to the engine, you see different items. One of them is special function. So if you open the special function, you have one option for resetting eCVVT values. But what you are actually seeing right now on this video is vehicle software management. This is based on Kia and Hyundai original scan tool, or GDS, or the new KDS that they use in the dealership. But doesn't really matter because the procedure is exactly the same. If you are using the GDS, you need to connect to the engine and use the and open vehicle software management. But otherwise, if you are using any other kind of a scan tool, after connecting to the engine, find the special function. Inside the special function, you have resetting eCVVT values. And what happens after selecting this item, you see, this function erases electronic cam position learning value. And the condition is easy: ignition on, engine stop. So you don't need to provide or prepare for anything specific. But there is something that you need to consider. When you erase the value, when the electronic cam position learning value is erased, cam position learning begins at the time of cranking. It means right after you do the resetting, when you want to crank the engine control module starts to perform the relearning, okay, for the cam position. So obviously engine control module won't be able to or will not start the engine, okay, until the learning is completed. So you should expect after resetting the values, you should expect something like a delay in starting. So that's okay, that's completely normal. So you see, this is the this is what we have in the scan tool. Cranking time extends in case of cam position learning, and it's necessary to keep cranking for 2 or 3 times at most. Okay, so keep cranking the car until learning is complete, and everything would be back to normal. So actually, these 3 steps are different when you have the eCVVT. You don't need to look for OCV or VVT solenoid anymore, because we don't have uh, that old mechanism anymore. So you don't need to find the OCV, you don't need to remove it, you don't need to clean or wash the OCV, you don't need to check anything for OCV, because technically you don't have any OCV anymore. And for the eCVVT, you can only check the power supply, you can check the negative wire or control line, and you can reset the eCVVT value using the scan tool, like the way I explained to you. For any other things, like for checking the camshaft sensor or crankshaft sensor, you can just refer to the previous video that I made for P0016, because they are all the same. I hope you guys enjoyed the video. See you soon in another episode.